Okay, now chapter 6, data preprocessing in machine learning. In this chapter, we will study data preprocessing techniques including feature scaling, feature selection, and feature importance. Let's go to section 6.1, general remarks on data preprocessing. Data preprocessing is a kind of data mining technique. It involves transforming raw data into a understandable and more tractable format. Real-world data is often not well organized. It can be incomplete, redundant, inconsistent. Data preprocessing is a proven method of resolving these such issues. It is often the case. Data preprocessing is the most important phase of the machine learning project. Okay, here we have 4 different steps for data preprocessing. First one is data cleaning. The main thing for data cleaning is elimination of noise and outliers, and also minimizing some duplications. And second step, data integration. This is for combine and the data sets into one in consistent format. And data transformation, and through this step, you can scale the data. For instance, normalization, so that the future, the columns can be changed into the normal distribution, and centered 0 and standard deviation is 1. Now finally, you may try to do data reduction. Through this step, redundancy within the data can be removed and efficiently organize the data. Here, one comment is that the more disciplined you are in your handling of data, the more consistent and better results you are likely to achieve. In machine learning, more important thing is better data rather than better algorithms. Okay, here we have a remark. Data preparation or data preprocessing is difficult because the process is not objective. And also, it is important because machine learning algorithms learn from data. And however, this data preparation is time-consuming, and often it takes up to 80% of the time. And also, the data preparation is not a once-off process. And during the machine learning algorithm development, you have to go back to the data preparation again, iteratively. It is very critical that you should feed the algorithms with the right data. Okay, and there are some questions often asked in machine learning. What would reduce the generalization error? And through good data, you can do it. So that here, another question is, what is the best form of the data to describe the problem? And it's not easy to answer this question because it's not objective. And so that somebody may ask a question, can we design effective method or smart algorithms for automated data preparation? Okay, That's the end of section 6.1. Thank you.